Hi, today we're going to talk about the basics of chemistry. An atom is the smallest unit of matter that still retains the properties of an element. As you might remember, we talked about the levels of organization, and so the smallest level that we talked about were atoms. So when you think of the periodic table of the elements, all of those elements are going to consist of one kind of atom, and they can't be broken down. So if you're worried about whether something is an element or not, just think, do I see this on the periodic table? And if you do, then it's an element. A compound is going to be a combination. So compound, combination of two or more elements in definite proportions. When we're looking at the levels of organization, we had atoms, molecules, cells. Okay, and so molecules are going to be a group of two or more atoms together, right? So molecule and compound, kind of think of them as together. We have a water molecule, right? We're combining two hydrogens with an oxygen. You cannot find water on the periodic table, but you can find hydrogen and oxygen. Those are the elements, but they're going to come together as a combination or a compound, also called a molecule, a group of two or more atoms. This should be a review, but atoms are composed of subatomic particles. We have a proton, which is positively charged, an electron, which is negatively charged, and neutrons, which are electrically neutral. And here we get to see how those play out. So we have in here, that's going to be our nucleus. And so in the nucleus, we're going to have our protons and our neutrons, and then in the space outside the nucleus, that's where we'll see our electrons. And again, this should be a review, and we'll just go over it again. But the atoms, the protons and neutrons of that atom are going to be found in the nucleus. And remember, whatever atom that we're looking at, it's based on the number of protons. So the way a certain element is going to behave and act is due to how many protons are in the nucleus. And then again, outside, we're going to see electrons. And this gets very complicated. We're going to keep a lot of those energy levels and orbits for chemistry. So we'll get into a little bit, but just know that they are way more detailed than what we get into. All right, so electrons, they're always going to be in constant motion. They have different shells or energy levels or orbits that they can be found in. And so the first energy level, the first shell that's going to be closest to the nucleus, can have a maximum of 2 electrons. This is an abbreviation for electron because they are negatively charged. In the second shell, there can be a maximum of 8 electrons. And again, there's way more details to than what we're talking about, but for our purposes, we just need to know 8 electrons are in the second shell. So if I have 6 total electrons, 2 are going to fit into the first shell, and then 4 are going to fit into the second shell. A balanced atom just means that there's no charge, okay? And so to have a charge of 0, right, we need to have the number of negatives equal the number of positives. And so the number of electrons in an atom should be equaling the number of protons if it's a balanced atom and there is no charge. So again, if I have 6 protons, then I'm going to have 6 electrons, all right? And then again, 2 are going to be in that first shell, and then the next 4 are going to be into the second shell. If I have 8 protons, then I need to have 8 electrons. 2 into the first shell, and then 6 into the second shell. So our periodic table is going to help us figure a lot of things out. The atomic number that you'll see on the periodic table, that's telling you the number of protons. And since protons equal electrons, that atomic number, if it's a balanced atom, will also tell you the number of electrons. The mass number is just simply the number of protons and neutrons, so it's pretty much the mass of the nucleus, because in the nucleus we see the protons and the neutrons. So if the protons are given to us by the atomic number, all we'll need to do here is subtract mass number minus atomic number, and that will give us the number of neutrons. So carbon here is pretty easy. Well, easy math, but we'll take 12 for our mass number, that's protons and neutrons, and we'll subtract 6, which is our atomic number, which is the number of protons, and then that tells us that there's going to be 6 neutrons in an atom of carbon. So if I want to figure out what are the protons, neutrons, and electrons in the carbon atom, the number of protons, the atomic number, 6 neutrons. I did this math, so I figure out that that's 6. And since my protons equal electrons, then I know that that's 6. They all don't always add up to be the same number, so don't get confused or think that that's always the case. You just have to always be looking at atomic number, mass number, and that will tell you how many of each of the subatomic particles that a particular balanced atom has. Okay, so now we're going to change some things up, right? So we have 3 parts to an atom: protons, neutrons, and electrons. And so protons are always going to stay the same. If I'm looking at carbon, I'm always going to have 6 protons. But if I change the number of neutrons, or in nature, if the number of neutrons are going to be different, then we're going to call that an isotope. So isotopes are when we change the number of neutrons. And if I change the number of neutrons, then I'm also changing the mass number. So here's our calculation for what we figured out. This carbon-12 is what we see in the periodic table. So the mass number is 12. That's where that 12 comes into. And so we've had figured out on the page before. So our protons, 6, neutrons are 6, electrons are 6. But for a isotope, right? So isotopes, now I'm going to have 7 neutrons. So isotopes, I'm changing the neutrons. And so because I changed that number to 7, that means that my mass number now has increased to 13. Carbon-14, for when we're dating old fossils and things, is 14 because I've changed the number of neutrons to be 8. Okay, so years ago, some kids came up with a way to remember it, and so I'll just pass that nugget of knowledge on. And so we remember isotopes by doing this phrase: isotope, nope, N for neutron. And so isotope, we're changing neutrons. Isotope, nope, N for neutrons. And when I change the number of neutrons, I'm also changing the mass number. But because my protons have not changed, I'm still looking at carbon. I'm always carbon if I have 6 protons. Radioactive just means that the nuclei are unstable and break down at a constant rate. And so here are some applications of how radioactive isotopes are used in the real world: to age fossils, to treat cancer, kill bacteria, to trace substances. When you go in for those PET scans and different parts of your brain are lighting up, that's all due to radioactive isotopes. All right, so now if I go back to my balanced atoms, right, I'm looking at protons, neutrons, and electrons. Isotopes are changing the number of neutrons. But if I change the number of electrons, then I'm going to deal with what's called an ion. Okay, so if I go back to a balanced atom and kind of figure out what should be the number of electrons, which should be the number of protons, right? So when protons equal electrons, that's balanced. It's a balanced atom. But when protons do not equal the number of electrons, now I have an ion. And this also means since electrons are negative and protons are positive, because now one might be more than the other, I'm going to start to see a charge. Okay, so ions are also charged. So if I've gained a negative electron, if I have more negative electrons than I do positive protons, then my overall charge is going to be negative. If I lose electrons, now I'm going to have more positive protons than I do negative electrons, so my overall charge is going to be positive. This becomes important, especially when we get into bonding, which we'll talk about later, coming up pretty soon. But when an atom gives away an electron, so here's an atom and here's another, and when it gives away an electron, this guy is going to, it will have lost an electron, and then this atom over here will have gained an electron. And so those different opposite charges, those different ions, are going to be involved in ionic bonds. But at this point, right now, we just need to know that ions are when we change the number of electrons. Okay, so I'm either gaining or losing the number of electrons. They do not equal the number of protons of an atom.